To go over a bunch of practice problems involving trig, whether it's solving equations, simplifying, identities, graphing, whatever the case be. I'm going to start right here with these problems right here. Number one is a complex fraction, right? We have two fractions in the numerator and a fraction in the denominator. Well, as the case is with most fractions, the common denominator plays a pretty big role in it. So I'm going to multiply by the common denominator divided by the common denominator. In other words, a fancy form of 1. And just for somebody maybe he's not too clear, right? This right here is nothing different than a fancy form of 1. So I'm just multiplying by 1. So when I distribute cosine times sine over to here, my cosines cross out and end up with sine squared of x plus when I distribute this guy into here, my sines cross out. I'm left with cosine squared of x. And when I distribute here, the entire denominator crosses out with this entire piece. So I'm left with over 1. And we all know sine squared plus cosine squared is 1. So my final simplified version of that complex fraction is simply 1. Number 2 is really the same problem, except you got to write it as the complex fraction first. Secant is 1 over cosine. Cosecant is 1 over sine. Tangent is sine over cosine. And 1 is basically whatever over whatever. I'm going to go, since I have a cosine here, I'm going to make it cosine over cosine. Fancy form of 1. And I'm going to begin the process all over again. Multiply by my common denominator in a form of 1, which will be cosine times sine again. Y being my variable this time, cosine y times sine of y. So when I multiply over to here, cosines cross out, I'm left with sine of y. Plus here, sines cross out, I'm left with cosine of y. In the denominator, cosines cross out, I'm left with cosine times sine. Excuse me, got a phone call. Okay, I'm back. Sorry, important phone call I had to take there. It is it's tax season these days here. So where were we? We were multiplying by a fancy form of 1, which is our common denominator over the common denominator. Numerator, cosines crossed out, sines crossed out, denominator. We end up with a cosine crossing out, so we have cosine y times sine of y. Plus over here, cosines crossed out, so we get sine squared of y. Well, nothing I can do in the numerator. Numerator is no like terms. Denominator, however, notice we have sines in both terms, so I'm going to factor a sine out. Over here, cosine is remaining. And over here, a sine is remaining. And fancy that. Numerator, sine plus cosine. Denominator is a sine plus cosine. So I'm going to cross them out. And I'm left with 1 divided by sine, which we also know to be cosecant of y. So there are the first two problems. Scroll down here, look at 3 and 4. And this number 3 here looks like it's pretty straightforward, right? Cosecant is 1 over sine. So sine times 1 over sine minus sine gives us 1 minus sine squared. And think about that. We have sine squared plus cosine squared equals 1. So if I subtract sine squared, this is simply cosine squared of x. Over here, I'm looking at this guy. It looks like I can factor a cosine out of each term. I'm left with cosine squared plus sine squared. Oh boy, this is a gimme. So that's cosine times 1, which is just cosine. Here, cotangent 90 minus x is the same as tangent. So I'm going to write tangent as sine over cosine. Cosines cross out. I'm left with sine of x. Tangent 90 minus x, same as cotangent. So what do I have here? I have sine, and then cotangent is cosine over sine, plus cosine, over 2 cotangent. So here we got a couple signs that cross out, and I'm left with cosine, cosine, so 2 cosine over 2 cosine sine. 2 cosine over sine. 2's cross out. Dividing by a fraction is the same as multiplying by the reciprocal. Cosines will cross out, and I'm left with sine of x. And that is all for page 1. We'll move forward to page 2 now. Page 2, we're proving the identity. I make one side look like the other side. Well, if you remember your identities, 1 plus tangent squared is secant squared. So tangent squared looks like this. And secant squared looks like this. And boom, boom, we're left with sine squared. We've proven it. Let's see, cotangent squared is nothing other than cosine squared over sine squared. Now I know a lot of you will just want to say, oh, well, this is an identity. All of these are identities. Okay, this is equal to that. They are equally interchangeable. You can't just say to prove something that, oh, sine squared equals sine squared. You need to work your magic. You need to go through and make things look differently. So that's why I can't just use that Pythagorean identity we derived in class. Cotangent squared plus 1. Well, I'm going to change 1 into sine squared over sine squared. All right, still 1, because now I have common denominators, and I can say cosine squared plus sine squared over sine squared. In other words, 1 over sine squared. In other words, cosecant squared. And we're done there again. Put equal signs here. Technically, right? We got to make sure everything's equal. Scroll down to a couple more identities. Tangent squared plus 1 is secant squared. See, I can use this now because I'm not proving that particular identity. Cosine squared minus 1, you have to be careful. 1 minus cosine squared is sine squared, so cosine squared minus 1 is negative sine squared. And that would be 1 over cosine squared times negative sine squared. Well, this is equal to negative tangent squared, so we end up with negative sine squared over cosine squared, which is negative tangent squared. Checka! This one looks like an interesting one here. I'm going to take a second to think ahead on this one. I could give common denominators if I wanted to. You know what, though? I'm gonna go wild on this one. I'm going to change everything into sines and cosines. And, oops, notice the little typo here. That should be tangent of x. So here's tangent. And that's over 1 plus 1 over cosine. Plus 1 over cosine. And here's tangent sine over cosine. Now I'm going to multiply everything by cosine over cosine. Common denominator. Remember I said everything. So in my numerator, cosines here cross out, I'm left with sine. Over, here I get cosine plus 1. Plus, now over here I get cosine plus 1. And here I get over sine. So it didn't really change the layout too much, but I think it's going to be a little easier to work with. I'm now going to give common denominators. In other words, I'm going to multiply this one by sine over sine. And this one by cosine plus 1 over cosine plus 1. Forms of 1. So here I get sine squared over sine times cosine plus 1. Plus here I'm going to get cosine plus 1 quantity squared, and the denominator, obviously, the same as the other denominator. That was the point of doing this, to get the common denominator. So now I combine and get sine squared plus, we'll distribute that. You get cosine squared. Oh, that's convenient. Middle term will be 2 cosine, and the last term is a 1. And that's all over sine times cosine plus 1. Scroll down a little bit here. A couple things disappeared, so I'm going to go forward and backward to bring them back, hopefully. So sine squared plus cosine squared is 1, and 1 plus 1 is 2. So I have 2 cosine plus 2 over sine times cosine plus 1. Factor 2 out of the numerator. And I get a cosine plus 1, which is exactly what I have in the denominator. Cosine plus 1s are gone. 2 over sine is the same as 2 cosecant x, which I believe is what we were looking for. There it is. Cha-ching. Got it. Let's look at page 3 here now, some graphing problems. So we got a negative sine graph, so I'm going to do this one using my sinusoidals. In other words, I'm going to move my axes instead of moving my graph. So there's my sinusoidal. A negative sine graph looks like this. This particular graph moved up 3, has an amplitude of negative 4. Sorry, has an amplitude of 4. The negative, put the negative sign in there. Has a period of 2 pi divided by 4, which is pi over 2. And it had a shift right of pi over 4. Before I do that, I'm going to draw on my x-axis, which is just above negative 1. I'm going to cheat and use a line drawing tool here. There we go. That looks like a good spot for it. There's my theta axes. We move to the right pi over 4, so this is now going to be labeled pi over 4. The period is pi over 2, common denominator, 2 pi over 4, right? So that puts this at 3 pi over 4, which means my middle value is pi over 2, 2 pi over 4, right? 2 pi over 4, which is pi over 2. Okay, so how much do I need to get back to the axes, to the y-axis? Well, I need a distance of pi over 4, right? Pi over 4 away, which is half of the graph. So I'm going to go like this. And right there will be my y-axis. And there's our graph. This one I'll move the graph and I'll leave the axes as is, but you still got to be a little cognizant to what's going on. This thing moved left and down, so I'm looking at third quadrant here. So when I draw my graph, I'm going to draw my graph like this: first, second, third quadrant. It moved down 4 and has an amplitude of 3. It moved left 2 pi and has a period of pi. Moved left 2 pi and has a period of pi. So 2 pi plus pi is pi. So my graph is going to be between here and there, with a center line right here. It's a positive cosine. Cosines start at the top, and they work their way through 0 to negative 1 to 0 and back up. So let's see, if this is pi and that's 2 pi, sorry, that's a negative pi. This is negative 3 pi over 2 right here, which means this would be negative pi over 2. We've got our little quarter marks here. And the graph working its way through again, because I'll need one more graph to come back to the axes. See if we can give it a nice little curve. And the difficult part for me is trying to hit these dots, which is why I like to draw my graphs first and move my axes. But that's not too bad right there. I'll take that. So there's our graph for number 12. Moving on here now to, whoa, everything's moving all over. Moving on here now to 13. I'm going to go back to my sinusoidals here. This is a negative cosine graph. So my negative cosine is going to look like this. Starts at the bottom and works its way up to the top and back on down. Graph did not move up or down at all. So this actually is my axes, my x in this case, axes. I moved to the right pi over 6. And yet I wrote it too, pi over 6. My period is 2 pi over 6, which, right, is pi over 3, but for my purposes, I'm going to leave it as 2 pi over 6, because that's going to put me at 3 pi over 6. 3 pi over 6 is known as pi over 2. This would be 2 pi over 6, or pi over 3. Okay, so to come back, I need to have one full graph, right? This was 2 pi over 6, which is our period. Let me look at that again. Our period is pi over 3, I'm sorry. So pi over 3, and I'm pi over 6 away, so I need half of a graph. So we're going to go like this, and we're back. So my values, this did not move up or down. I had an amplitude of 2 though, so this value is 2, and this one is negative 2. And that looks like our entire graph there, x and y. For sine, again, I'll do sinusoidals here. We'll go down here though, just in case we got to come back to the left distance. This one moved down 4, amplitude of 4. So that actually takes me to my axes, right? Take me to your axes. There it is. That's x. Extend a little more here, kind of foreshadowing maybe. And we go all the way down here to negative 8. And this is a sine graph. I forgot to draw my graph. How about that? There's my sine graph. We move to the right 4 units. We have a period of 2 pi divided by pi. So our period is 2, which means I go from 4 to 6. I'm 4 away. Well, that's going to be 2 graphs. There's one graph. Oh, bad turn there. I'm going to undo that one. Yeah, missed again, but there we go. That will be my y-axis there. Boom. Negative 4. All right, I'm going to go forward and back to get one last look at that graph with everything reattached to it. Okay, negative 4 all the way down to negative 8. There's my axes there. Not too bad. All right, last page here then. Some solving stuff. That's a 1 over cosine there, so I'm going to take this entire thing and multiply by cosine. So I get 2 cosine cubed minus cosine squared. And now I want to subtract 2, so minus 2 cosine. And I'm going to add secant, which is 1 over cosine. So it becomes a plus 1. 4 terms is a grouping problem. Cosine squared is going to come out of the first 2 terms. I'm left with 2 cosine minus 1. These 2 terms have nothing in common, but I need to look at like a 2 cosine minus 1, so I'm going to pull out a negative 1. Be left with 2 cosine minus 1. Now I have 2 terms instead of 4 terms, and those 2 terms each have 2 cosine x minus 1 in them. Pull it out of the first term, I'm left with cosine squared. Pull it out of the second term, I'm left with a minus 1. Set them each equal to 0. This one tells me that cosine of x equals 1/2. This one tells me that cosine of x equals plus or minus 1. So when does cosine equal positive 1? What happens at 0? Don't go to 2 pi though. And negative 1 occurs at pi. Cosine equaling 1/2 would be our tall triangle, which is pi over 3 in the first quadrant and 5 pi over 3 in the fourth quadrant. There are 4 answers for us. Properties of log says 2 to the negative 1 equals cosine. In other words, 1/2 equals cosine, which means x is, I'm going to cheat and look at my last answers, pi over 3 and 5 pi over 3. I'm going to change tangent squared into secant squared minus 1. Multiply and combine like terms. 2 secant squared minus secant squared is a secant squared minus 2. So secant squared equals 2. So secant equals plus or minus the square root of 2. So cosine equals plus or minus 1 over root 2, which means cosine equals plus or minus root 2 over 2. Rationalize that guy, right? For those who forget about rationalizing, multiply by a fancy form of 1. And we're looking at root 2 over 2 in every quadrant. So we've got pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And here we are in the last one. I want to change cosine squared into 1 minus sine squared. Just to give all like trig functions. Distribute. And then I'm going to multiply by negative 1, or if you want to think about moving everything to this side, I'd like my lead term to be positive. So that's a positive 2 sine squared minus a sine, and my 2 and 1 will make a 3. Subtract to the other side, multiply by negative 1, whatever you're doing. It's now factoring 2 sine, multiply to 3 by a 3 and a 1. If I put the 3 here, that gives me a 6. That's too much for the middle, so I need the 3 here and the 1 here. So I have 3 sine and 2 sine. So I need a negative 3 sine and a positive 2 sine. So this tells me that sine equals 3/2. Well, that is impossible, so I get nothing from there. And this tells me that sine equals negative 1. I know that occurs at the bottom of the circle at 3 pi over 2. And there you have it. I'm going to go forward and backwards as some of this stuff disappeared, so you get a final glimpse of all the correct answers and everything that goes with them. And that was the video for today. Hope you enjoyed it. We'll see you on the flip side.